Okay, so let's take a look at this mechanics stroke energy question. Alright, so you might want to pause the video to read it. Okay, so it says we've got this car towing another car up a hill on a slight incline of 5 degrees. It's saying that you can ignore the friction in this car, and there's a simplified diagram of it here. It says car A has a mass of 970 kilograms, so this one has a mass of 970 kg. Show that the component of its weight that acts parallel to the slope is approximately 830 newtons. So this diagram is kind of helpful, but it's a bit too small for me to really see what I'm doing, so I'm going to just draw a bigger one. So exaggerate it, that's your 5 degree. Right, just make it a bit bigger. Okay, so you've got mg acting directly down, and what we're going to do is we're going to split up mg into two components. Mg acts directly down, and if I draw a dotted line perpendicular to the slope, right, and another line parallel to the slope, right, then what I can say is mg could be made up of a vector like this, right, and a vector like this. And it is that vector here that I'm looking for. That's the vector that will be the component of weight acting parallel to the slope. If this angle here is 5 degrees, because of the way I constructed this triangle, this angle must also be 5 degrees. This is the hypotenuse of the triangle. This is the opposite of the triangle because it's opposite the angle. So I can use sine of 5 degrees should be equal to the opposite divided by the hypotenuse. In this case, the hypotenuse is mass times gravity. Okay, so if I multiply both sides by mg, I can bring it up, so it becomes mg sine 5 will be equal to the opposite angle, sorry, the opposite side, which is actually the component I'm looking for. So mg is 970 multiplied by 9.81 multiplied by sine 5. Okay, make that clear, sine 5. And crunching the numbers, 829 newtons. Okay, so that means it's a show that question, so we were already given the answer. The examiner's giving us a helping hand there. Let's move on to the next part of the question. Again, read ahead, pause the video and read ahead if you want to try the question yourself. Okay, so if you look at the equation sheet that you're provided with for this question, you're given two useful equations. You might jump straight to I'm being asked for energy stored, so the equation for energy stored that you're given on this, by this exam board anyway, is a half force times the change in length, right? But I don't have the change in length. But I am given another equation, which is the Hooke's law equation. Force is proportional to, or force is equal to spring constant times change in length, right? And whilst we're at it, we may as well talk about the fact that this formula usually isn't that useful. You have to sub this formula in some form or other into it. So you can see straight away I could replace the F here with KL. So if I replace the F with KL, I'd end up with E equals half. Let's just quickly do that then. E is equal to a half KL squared, right? So that would be a useful equation if we didn't have the force, but actually we are looking for a version of this formula where all I need is the spring constant and the force. So it's the length I don't have. If I rearrange this equation for L, so delta L would be equal to F over K, I can then substitute this in for delta L, which gets me E equals a half F times F, right, over K, so it becomes F squared over K. And I can just use that equation to calculate the energy stored. So that would be a half times 829 squared divided by 2.5 times 10 to the 4. Okay, and when I crunch through this on my calculator, I get a value of 13.7 joules. Okay, so my answer is 13.7 joules. Right, moving on to the next question, next part of the question. Again, pause the video if you'd like to read it properly. Alright, so now we're being told that the rope is attached to a fixing point on car A, so that's the car that's being towed, and during the ascent, during the climb, the fixing point snaps and the metal hook becomes detached, and the metal hook gains speed due to the energy stored in the rope. State and explain how the speed gained by the hook would have changed if the rope they had used had a greater stiffness or greater than 2.5. Straight away, I can see the examiner is trying to lead us into thinking about this question and help us out really. They've just got us to do a question calculating the energy stored, right? And that is the energy stored in the rope, right? So let's just see what would happen if I made that number bigger, okay? Let's say I doubled it. If I made this number twice as big, then this number will become half as big, okay? So immediately I can see if I make the stiffness greater, the energy stored in the spring would be less, right? This might be a good time to think about where actually all this comes from, right? If you've got the force length, change in length graph for a spring, as you stretch it, force increases and length increases, and if they're proportional, it's following Hooke's law, and this area is equal to the energy, right? If you make the spring a lot stiffer, right, then you actually end up with less area under the graph for the same force. So really that's what this is talking about. Because there's less energy stored, there's going to be less kinetic energy as a result of that. So now we have to think about how to structure our answer. The examiner's report for this question did say that students really struggle to structure their answer well with this, so I'm going to try and really make that clear. So we might start off by mentioning less energy would be stored as strain okay, due to less extension. Okay, so that's point 1, that will be worth 1 mark. Therefore, less strain energy would be available to be converted into kinetic energy. Right, another mark. And then finally, therefore, I'll use the dots now because I think my handwriting is terrible. Therefore, less speed. Okay, and I think that should really get you the 3 marks. Okay, I hope you found this useful. If you aren't sure, comment on the YouTube channel and ask for more help. Thanks for watching.